Hello everybody, my name is Maxim Rylov and I'm a researcher at GIS Science Research Group, Heidelberg University. Today I want to present you the results of our research, which has been conducted together with one of my colleagues, Andreas Reimer. And the topic of my talk is cartographically plausible label placement. And more precisely, I will talk about the multi-criteria model for good point label placement, which can be applied to label OSM-based maps. So, what were the motivations and goals of our research? Lettering and design are both equally important in manual cartography, but unfortunately, the importance of lettering is neglected on modern web maps. And the research in the field of automated labeling is being conducted more than 40 years now, and but nevertheless, the labeling on automatically generated maps are still poor and untidy. As you can see from the figures, the algorithms are quite bad in considering cartographic knowledge. The deficiencies in automation impel the map designers to thin out the map content. As you can see, a comparison between number of labels on automated lettering map and manually lettered map. So, now our research, we tried to develop a model that considers almost all well-established cartographic rules for point feature labeling. As a data set for our experiments, we have chosen the rich OSM geodata. One of the goals of this research was to present the data which is currently hidden from us, especially on small scales of the map. So what is the cartographic lettering and the purpose of this subject? So the good lettering helps a reader to convey geographic information data. There are several rules, but the main rules from cartographers are that the labels should be clear and have clear graphic association. They distinguish four main constraints. For example, to place as many labels as needed for the task, and at any cost, the cartographer should strive to avoid ambiguities between neighboring labels. Moreover, to avoid unnecessary cluttering of the labels. Furthermore, the next cartographic rule is that the background information is quite important also, and the text and the background should be in harmony and to overlap, and the labels should overlap the background features as little as possible. And it is highly important to note that all the online maps, most of them, do not consider none of these constraints in map lettering. So what is actually automated label placement problem? For point feature label placement, this problem is NP hard, so you can imagine that it's quite difficult to solve it. And that's why this problem is divided into three subtasks, such as candidate position generation, which is, we have the points on the map, and for each point we generate some number of candidates. Then in the second subtask, we use some quality function which scores those candidate positions using different criteria, which are based on cartographic guidelines. And the final subtask is position selection, which is just solving the problem. It means some algorithm that tries to find the good approximation to the global optimum of the problem. It is worth noting that currently most of the maps use only two criteria, like positioning around the symbol and the importance of the feature. The rendering toolkits like Mapnik or GeoServer use these rules, and they also use some kind of greedy algorithm inside, which is quite bad in performing this task. I would like to note that there are many more criteria or cartographic rules that have to be considered, like background feature overlap, cluttering, disambiguation, or coastal places. And furthermore, there are many better algorithms than greedy algorithm that solve the problem of label placement much better, like this algorithm, simulated annealing genetic algorithm, sotm-eu search algorithm, or different artificial intelligence procedures. So, our multi-criteria model is a pure linear programming model, which is expressed as a quality function, which has a sum of single metrics, where each matrix corresponds to one of the cartographic rules. Here you can see these metrics are denoted as F. So the metric for priority, for positioning, and feature overlap, and so on. In my talk, I will present you only 4 of 6 metrics, which I think is enough for you to just grasp the model. And don't be afraid, there won't be any other slide with mathematical notations, just boring for you. So, point feature label placement is a task of putting the label around the symbol we want to tag. And the cartographers are very precise in performing this task. So, they take into account different issues like optical coincidence, legibility, and the presence of ascending and descending letters in the name. And here on the screen, you can see 2 commonly used models for positional prioritization. On both examples, the rectangle with number 1 is most preferable place for the label. So the second metric that we used is priority metric, or the metric of importance. The different in presentation of different names helps the reader to see the difference in population, the importance or administrative status of the place. Here you can see an example where Frankfurt am Main and Worms are presented in 2 different styles. But thanks to OSM data tagging scheme, there are 2 nice tags which can be used for this task. They are the tags place and population. So these tags normally used in styling or in filtering, and also they use in this model to weight certain position or a certain set of the labels that belongs to one labeled feature. Another metric that we considered is the feature overlap metric. One of the cartographic guidelines say that we should avoid overlapping the background features like road network, water bodies, shaded relief. In our approach, we used a raster-based method, which consists of 2 steps. The first step, we apply some image segmentation algorithm to the background image, which is a raster image that contains background information. And the second step is we perform analysis to detect homogeneous regions, which are very attractive for placing the labels. On the figure below, you can see the workflow of this approach. And the fourth metric that we considered is the coastal place metric. To get to know if the point belongs to the coastal point, we need an additional attribute in the dataset, but it usually absent. And moreover, it doesn't work because for each certain scale, we need 2 different attributes because the point-shore relation is scale dependent. In order to tackle this problem, we proposed the following methodology. We used the coastline dataset from OSM database. Then for each point that we want to label, we construct the neighboring region and then try to find the percentage of water or land inside of it, inside of the intersection of these regions and original coastline polygons. This helps us to decide whether it is a coastal place or not. On the next slide, you can see the comparison of different maps of the same region that have been labeled using different data sets, different frameworks, and labeling settings. On the first 2 figures above, you can see standard mapnik and the tiles from the map box. These maps have quite few number of labels. In comparison, the Google Maps, they have many more labels, 54, but nevertheless, the map is still readable. What can we actually do with OSM data? As you can see on the last map, which has been labeled using our proposed model, we can see the same number of labels, even one more, 55. But in comparison to Google, we have all the city places are labeled, the names are positioned on the water. And the road network is much more open, especially you can see it on along the east coast. And we have enough space to put more labels here and keep the map still readable and legible. In our research, we have conducted a set of experiments, and here I want to present some of them, the results of some of them. In the table, you can see the results of the labeling tested region, which is placed in northern part of Denmark. And from this table, you can see that simulated annealing algorithm using 6 metrics is able to place 15 labels more than greedy algorithm, but it takes much more time to complete the task. From our experience, we can conclude that the performance and the quality of the labeling depends on the number of input labels, number of quality metrics, and the type of the solving algorithm. What are the pros and cons? On the one hand, we have the label placement of high cartographic quality, and our tested case simulated annealing in average gives 7% more labels for the globe. On the other hand, the task of the lettering is time-consuming and resource-intensive. Here is some more statistics. On this slide, you can see how much time does the greedy algorithm take to label the whole globe on the 10th zoom level with the 4 threads. As you can see, the greedy algorithm 10 times faster than simulated annealing equipped with all 6 metrics. On the next zoom level, 11th, we don't see such difference because the map becomes not, the labels on the map becomes not so dense. As a summary, I want to say that this model is presented and described in details in the research paper that you can find online. Then the model is given in such details that you can reproduce it in your own solution or in other existing toolkits like Mapnik, GeoServer, or MapServer. Furthermore, if you want just to see the results of label placement, you can visit OpenMapServer webpage, where the map with the lettering for the globe is presented. And the last, the proposed model was implemented within MapServer.net framework, which is another rendering toolkit that has an application where you can create styles, profile the styles, and then configure your labeling and create the tiles. So that's all from my side. Thank you for your attention.
Hi. So the base idea is that labels in the current digital cartography systems are not good, based on the on cartographical guidelines that from the field of cartography. But having a lot of zoom levels and the capacity, I mean, those guidelines were written because then in 1975 there was a limited space to put a map on. It was a piece of paper, and now we have a lot of zoom levels to distribute that data on. And if we want more detail, we can advance. Doesn't that make? Wouldn't we have new guidelines for that instead of using cartographic guidelines that are from?
In our approach, we don't consider changing of the zooms, and we do not label the whole globe on a certain scale at once. So we use also meta-tile approach when we render a label on a certain region. But then there is a problem of how to merge 2 different optimal solutions on adjacent meta-tiles, which we have some ideas how to do that, and prototypes of the system.
Is there some ways to calculate not only the position of letters and the angle of letters? As I can see, your application, your approach, and Google Maps and Mapnik, all these applications use flat lettering, all letters oriented horizontally. Is there some approaches to calculate not horizontal labels?
for point feature label placement, in cartography they use mostly only horizontal labels. But for this first subtask, you can generate different the text, which has another angle of rotation, and the model is still valid for any angle of rotation of the label placement.
Just for example, on the first slide, there was a beautiful map from our past. Yes, and as we can see, not all labels are horizontal. Some of them
Curved.
yes, some of them curved, and some of them not horizontal. And I think it may save some space, especially at the north coast.
Yes, it can definitely be done. One thing, we need to change the algorithm of generation of the candidates.
Okay.
And that's all. And probably to change one of the metrics that consider this ambiguity between the neighboring labels. But it's too complicated.
One thing that interests me, I've got a map rendering system which does labeling, and essentially it does what you describe as the priority plus greedy thing, and it uses the same priorities for point labels as you do. But one thing which I find very, very fruitful indeed is actually modifying the label itself, which I wonder if you considered that by, you can either do typographic things, particularly use condensed fonts, or you can look for abbreviations. So a word like street can be abbreviated to ST. And particularly in city maps, that's an incredibly useful thing to do. The other typographic thing is, of course, doing a multi-line label, which if you look at a city map will quite often have a street name rendered as 2 lines. But yeah, you did that in one of your town names, didn't you? But the actual modification of the label itself is the point I'm making. Do you take that into account?
No, because for instance, for abbreviation, we have more candidates. Like the first candidate is the full name, then the abbreviated name, and we need to consider all of them and try all of them and weigh all of them in different ways. But you still can use the same model. It's just nothing new, just a quality evaluation function.
Yes, I fall back to the abbreviation after trying the full version, of course.
Any other questions? Okay. Then I would say thank you very much.
Thank you.